Let me share my screen and let me know if you can see my presentation. You should be.
Yes.
Yeah, we see you.
Great.
Awesome. So welcome to our Friday Lightning Talks. And today I will share my thoughts and my first impression from touching React Native. 1 second, I will hide some unnecessary Zoom widgets. Cool. So this is a very opinionated introduction. I already have some background in React for web, so it will be mostly useful for developers who already know what is web development in React and know pretty much nothing about React Native. If you are watching it online and you have a question or comment, please feel free to ping either SystemSeed or me directly on Twitter. I will do my best to reply. This is me trying to figure out how to install and configure everything for React Native development. Why I decided to look into this? It turns out that pretty much everyone knows about this technology, React Native. This is a screenshot from State of JavaScript report. As you can see, like React Native is very popular. It's the second in overall mobile and desktop frameworks. And there are several other tools, but native applications basically means that you will need to learn Swift or Objective-C for iOS and Java or Kotlin for Android. Cordova is less popular because it's a little bit outdated, as well as Ionic. In other libraries section, we can see that Flutter gains popularity. It's alternative framework which has something in common with React Native, but it's written in Dart, and you are supposed to know Dart in order to build mobile applications in Flutter. While with React Native, you don't need to learn any new programming languages. You even don't need to learn a new framework because it's very similar to what we have in React for Web. So this all looks very cool. Let's check what we have on GitHub. So when we open React Native on GitHub, we can see that it is written in a half in JavaScript, and another half is in some other programming languages. Java is for Android native modules and connecting JavaScript to Android. Objective-C and Objective-C++ is for iOS, and C++ code is shared code base because obviously React Native core developers want to reuse some code between two platforms, and C++ is a good choice for that. So basically, React Native isn't just JavaScript technology. It's idea to allow us web developers to have some kind of abstraction on top of native technologies, and then React Native will figure out how to translate it, how to transform it in native calls. That's why we have all this code written in Java, Objective-C, C++, and so on. So when we work with this shiny devices, we actually have quite a lot of power inside of them. And React Native tries to use as much as possible of native device. This is very, very high level attempt to explain how React Native works, and obviously it's not precise, but I will try to explain some insights that were important for me when I started learning React Native. First of all, when you run your application on a mobile device, you have UI thread, and UI thread is for the user. It becomes busy because of the user, because user scrolls down, clicks buttons, switch screens, does something, and UI thread should be free for rendering of smooth animations, scrolling, and so on. Cool, so we have UI thread, and React Native does nothing directly with UI thread. UI thread is for user. Then we have JavaScript thread, obviously, because React Native is JavaScript tool, and half of it written in JavaScript. More precisely, it's called JavaScript core. So it's something kind of small subset of JavaScript runtime installed on your device that will execute JavaScript code provided by React Native in this separate thread, JavaScript thread. Then we have a bridge between JavaScript code, React Native code, your business logic that you've written in React Native, and native application, because another half of React Native is written in native code, because we don't want to render everything in web view. Instead, we want to use as much as possible of native device capabilities. And this bridge communicates some instructions from JavaScript thread to native modules, to native things. I don't know what it is exactly, but you can have many of them. Device can start, and device decides how to start those threads. And basically you have all this stuff running in parallel, which allows you to make your applications performant, smooth, nice, and so on. I think it's enough of architecture for now. Let's move on and talk a little bit about some obvious React Native benefits. And the first one is that Facebook uses React Native. I think that it's like pretty much everyone thinks that this is the benefit of using React Native. It's backed up by huge organization, and that huge organization runs many very popular applications like Instagram, Facebook, and a ton of other smaller messenger and so on. In fact, it's not true. Facebook has two other frameworks, native frameworks. One is called Component Kit for iOS. As you can see in the description, a React-inspired Vue framework for iOS. It's written in pure Objective-C, so pure native framework. And another one, Litho, for Android. So all very popular applications, Facebook popular applications, use this these frameworks or other native frameworks, and very small amount of screens and applications actually uses React Native. It's important to understand that when you open Facebook application or Instagram, primary Instagram screen, it's not React Native powered. Another benefit is that you can reuse code between web and mobile. That sounds great and logical. You have React in the title, React DOM or React Native, so should be able to reuse. Let's say we build a website, some small online shop, and then we just install React Native library, run one CLI command, and boom, we have it in mobile. It's not true. In fact, you can reuse very, very small amount of code between platforms. And let's talk a little bit about it. So on the left, I have a few examples of what we usually use on web when we use React. And on the right, some alternatives that you have in React Native. HTML. This is a well-known, very powerful markup language that we use on web. For example, we have div. In React Native, we have no div, and we don't have alternative for div. Instead, we have different types of views, and I provided just several examples. Safe area view, for example, when you want your screen to your view to render in places where user actually can see something, because you know that some devices they don't have 100% of their screen available for rendering. For example, you can have selfie frontal camera or something else. So safe area view. You can also have view, a flat view for long lists, and so on. And you have actually about a dozen of different views. H2, header or paragraph, text HTML elements. In React Native, you will have text element for all of them, plus some styling. The same goes for strong. URLs. This is great feature of web. You have identifier of every page of every screen you have in your website. In case of mobile application, you don't have URLs, but you have screens and you have some tools for deep linking, and it's not very trivial thing. It's kind of trying to integrate URLs into your application, but it's not natural for applications, so it's a bit complicated. CSS, another great technology that we use on web, and it's very powerful. You can cascade them, you can do some animations, you can use some latest prefixes with some cool stuff. I don't know, like it's very powerful. We as web developers like use it for years, and we sometimes forget how powerful it is. But in fact, it's not possible to port entire CSS into both mobile platforms, because what React Native needs to do, pick every CSS property and map it to corresponding behavior or look and feel in both platforms. And both platforms are different, so in some cases, it's just not possible. In case of React Native, we have style sheet component. This is subset of CSS. It's written in JavaScript, and you will have to write it in JavaScript. There are some API methods allowed to provide CSS-like behavior, but in general, it's different technology. Animations. Animations are tricky in React Native because JavaScript is slow. It sits in its own thread, and you need to communicate that you need to animate something to UI thread, and the only way to do it is through bridge and native modules and so on. So the implementation of animations is complicated. React provides abstraction called animated, and you wrap your views or other elements in this animated abstraction, and you can easily define how your animation should behave. You can also use native animations to instruct React Native that this view should be animated, and this view should be animated using native component, so JavaScript will not be busy while animating this. So the animations will be smoother, better, and so on. So it's completely different from what we have on web. It's not compatible at all. timers. In JavaScript and web, we have our good old timers. We all know how they work. They are tricky, but they work. In case of React Native, there is a mix of timers, because obviously time is something that you have on your device, and native modules should control these timers and when different events should happen. But at the same time, because we have JavaScript environment and we execute certain code in JavaScript, we have JavaScript timers as well, and you need to understand how it works. And again, it's not one-to-one mapping with what we have on web. I will wrap up this comparison very soon, but the last item is local storage and cookies. On the web, we can easily mark this user, set some token on the browser for this user using local storage and cookies. In case of React Native, in case of mobile applications, we don't have cookies, we don't have local storage. So all authenticated flows, all flows that rely on cookies on web can't be just executed on React Native. Instead, you need to use different approaches. One is async storage, but obviously I'm not an expert. Probably there are some other things. So this long list was to just remind you that web is huge. There are a lot of things that we use on everyday basis and assume to be trivial and available on every device. But in fact, when you want to run something on non-web environment in iOS Android device, you don't have all this stuff. You have some other stuff actually, and the last item in the right column is some components that we don't have on that. For example, status bar, refresh control. We don't have this on web, and each platform, iOS and Android, have their own non-standard elements, and React Native allows you to use those elements. So a lot of things going on. What it means? It means that, another screen just to show you some components available in React Native that don't really make sense for web. A lot of things here. That's the whole point of the slide. So, long story short, React Web into React Native, it's not possible. We can't compile our React DOM application into React Native. But the interesting thing that we can do it in the opposite direction. We can teach React Native how to translate these abstractions like safe area view or text or style sheets into web, back to web. And there are libraries that help do this. One popular library is React Native Web, and there are some huge vendors who use it. Another library is React XP by Microsoft. I didn't have a chance to review it, but they say that they also support desktop. React Native Web allows to render native applications on web. React XP provides additional abstraction on top of React Native, but then you will be able to run applications everywhere. When it is beneficial to use this approach, not always, but it is very beneficial when you have the same look and feel of web and mobile versions. For example, Twitter. In Twitter, you have pretty much the same functionality and look and feel on mobile and on web. Uber, again, in both cases, you want the same functionality, so you can potentially use React Native. If you build something different for web. Let's say on web you have one functionality, on mobile different functionality or different look and feel, then you shouldn't be using this approach. It will be just easier and quicker to build two separate applications. And in terms of sharing code, because there are so many different components and approaches to things, often you can share only generic JavaScript code, which doesn't do anything with browser APIs or device APIs. Let's say function to calculate sum of two numbers. You can extract this business logic in a library and then install on both applications. You don't necessarily need to try to build one application. React Native Web, I've got a couple of links to show you. The first one is example for Next.js. We love Next.js, and when I first noticed this example in Next.js folder, I couldn't understand what does this mean. Why React Native? Why web? And why Next.js? How it can be possible? The idea is simple, that you write your components. Let's open any component using React Native, not DOM, but React Native, for example, text, right? Like this. And then you can build web page, and React Native Web will translate this native components into web. This may be useful only in rare cases, I believe. I would prefer to use the full power of React Web in most cases. And another example is, if you still want to try this approach, there is very nice repository with example. It's real application. The guy built the application reusing almost 100% of code between platforms. The example is sophisticated. There is a corresponding article which you can follow. If you're interested, go ahead and read it. What I like about this example is that it is updated. So you can see that the guy updated it to the latest React, which is very nice. React Native itself is very fast. It's developed in a very fast pace. They recently added some nice features, so it's very good to stay on top. Okay, so I think it's enough about sharing code between platforms. Let's move on. And our next benefit is that you can write major part of your mobile application code in React style. And yes, this is true. And to get started, let's see some example. This will be very basic example. We will start with something very basic. So this is a one file application, which will ask you for your name and then show your name on the screen. Very simple. So let's just read the whole file. We will start from using React, and it's up to you how you manage your state. Entire React ecosystem is available. You can use Redux, modbacks, you can use hooks, whatever you want. Then we import some React Native visual elements. Text is to render text. Text input is to for user to input text. Save area view to output something. And style sheet to provide some styling, and animated, as I already mentioned, to animate something. Then I defined some styles. This is how you define them. There are some frameworks on top of it to make it a little bit nicer, but this is how you use it if you use just core. You provide some name, it can be anything, and then you provide your CSS rules. React Native layouts are powered by Flexbox. It's not CSS Flexbox, it's their own implementation of Flexbox, very close to CSS. And it is very powerful. Basically, you can do pretty much everything with it. So I use this Flexbox to center stuff on the screen. And then I also define some styling for my text input. As you can see, it's very basic. I will output it full width with fixed height, and the text that user inputs will be centered. Then our good old React components. In this case, I use hooks. I use state, nothing special, nothing specific to React Native. Then I follow documentation to initiate animations. Oops. Very interesting. I don't know, guys, if you saw they pop up on my screen. So then again, I use hooks to initiate animations using animated API, and then I render something. I render safe view. Depends on my state. I either display hello Kate or I display text input, and I export this component. That's basically it. Very, very straightforward, nothing special. If I remove animations from this example, then it will be just super basic without any React Native specifics apart from this components. Cool. And in terms of debugging experience, it's also very friendly, at least on latest React Native versions. This is a short video where I debug React Native on my real Android device, even without cable. I debug it over Wi-Fi. When I edit something in my editor, I can see these changes on my device immediately. And as well as that, React Native opens debugger, JavaScript debugger in Chrome, where I can debug every single line of my JavaScript. And it all works very fast. If I don't want to use a real device, when I can do the same on simulator. I don't like simulator because I don't have second screen. So I just want to have more space on my screen. That's why I use a real device, and experience was very, very good. Let's move on. Sorry, no, not. Let's go back, and I want to show you structure of React Native application when you initialize it first time, because it might be a little bit surprising. As I said, this Hello World application is very simple one file application. But in fact, we have a lot of stuff generated when we first initiate application. And this is pretty common structure for every React Native application. First of all, we have Android and iOS folders. And you must have them. You may not need to edit anything here till certain point, but you must have them because React Native will build application using Android build tools or iOS build tools, depends on which device you want to run, and it will do it using available Android tools and available iOS tools. It will not reinvent the wheel. That's why you have them here. Also, you will be able to do some customizations on native level if you need, and at some point it may be useful. Bug config, I have no idea what it is. ESLint file for ESLint. Flow config. Flow, it's kind of TypeScript from Facebook. You don't have to use it, you can just remove it. Git files, prettier, again, it's up to you if you want to use prettier. Watchman config, by default, React Native works with Watchman. It's kind of node-mon built by Facebook. It works fine. I didn't need to configure anything, and I don't know why we need this file. It just sits here. App.js is entry point for our application, and this is where I edit my code. App.json is some metadata about application. Babel, just Babel config. Again, I didn't need to change anything. Sorry, index.js is entry point, and app.js is root component. Metro config. Metro is kind of webpack, but for React Native. It just works. When you execute command React native run, blah, 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 Metro will start watching your files, compiling them into JavaScript that is supported by device, and will in real time deliver this JavaScript to your device so you can do live reload. Package.json lists all packages installed by default, and in my case, it will be very, very small. As you can see, just React and React Native. Cool, let's move on. Next thing is how you can start. So this structure that I just demonstrated you is built by React Native CLI. It's one command tool, React Native, init, and name of your application. This one is recommended. It's official. It uses latest stable release, so you can benefit from latest version of React Native on your new project. It doesn't create any boilerplate for you. Like all these files that I showed you, they are basically must have. Apart from maybe flow config or prettier config, you can easily remove them. The rest is very minimum. You have app.js and you start building your own stuff. And this is recommended by experienced developers because they like when they have very bare minimum installation. Another starter, which is very popular, and you will see it in many, many examples, is called Expo CLI. And even official React Native documentation suggests to use Expo CLI if you are not experienced enough. The problem with Expo is that it is third party, and the guys provide some paid features. They build something on top of React Native. This is crazy stuff, by the way they run our application inside of their application. So you don't need to build something, you don't need to publish something. You have everything inside of their application until you decide to release your real application. But obviously it limits and locks you inside of their framework. Some nice feature that
Kate, interruption. There's one addition to that. It's not really limiting to Expo CLI. There's a way to extract your application from Expo CLI. Eject. Yes.
Yeah, so ejecting means that you will get what you have in React Native CLI, but in this case, why you need to start with Expo if you will need to inject at some point anyway.
It provides a faster kickoff, some better tooling. At least that's what I've heard. It doesn't lock you in Expo CLI. So if you will need this at some point, you just eject, and you got the React Native stuff straight away.
So my
Just a
opinion is indifferent, and it's based only on some information that I read and watched on YouTube. The idea is that basically you either logged with Expo CLI tools that they provide. They have their own SDK, they have their own CI, all this stuff, which allows you to hide to hide those iOS and Android folders. But if you go and Google, like, I want this nice animation for React Native, or this thing, and you will find a library, you most likely will not be able to connect it to your application until you eject. So it's not clear to me what is the benefit. Speaking about quick kickoff, you just follow React Native CLI guide, how to start. You just read every line. Okay, install this, install that, run this command, and you're done. And you will have latest React Native without anything between. I like this to understand framework better and to be able to play with external libraries. Anyway, moving on from Expo, one interesting thing that Expo has is embedding React Native code on web, so you can very quickly test things on web. And many tutorials have embedded Expo view, so you can quickly see how it works, which is nice. Another tool which I found and which was promoted on React Native documentation page is Ignite CLI. Ignite CLI is built by a company, Infinite Red. They built mobile applications professionally, and they basically built their own boilerplate and open sourced it. And it became very popular because they also support external boilerplates. Let's say System Seed wants to have their own boilerplate with our own tooling. We can use Ignite CLI to spin up our own boilerplate. Infinite Red provides two starter kits. Oops. Sorry about that. Two starter kits. First is Andros, based on Redux and Redux Saga. It's a little bit outdated. I spent some time trying to run it on Android, but in general, it works. The other one is latest greatest, as they say. It uses another tools for state management. They use MobX state tree and they use TypeScript. Both boilerplates are very good examples of how you can build something, like say tractor, using React Native. You don't necessarily have to use it to start your own application because the boilerplates are quite opinionated. And let's say I wouldn't use certain tools that they use, but it is very interesting to see some examples how real company uses certain tools and native libraries in React Native development. I will probably just share the link to this repository where you guys can see the resulting applications. Let's just quickly see this one. This one is based on older Ignite boilerplate that uses Redux and Redux Saga. And I will just show you that there is no rocket science. And dependencies, all this stuff until React Native is just generic React stuff. Library for fetching data via API and some helpers and other helpers and React. Then we have some React Native React Native libraries, and it is very interesting to see how they can be connected and used in this boilerplate. And then another set of libraries that are generic. In this case, the guys use Redux and some helpers on top of it. And pretty much the same with the other boilerplate. You can go to app folder and see some examples of components, of style guides. So very, very interesting read. But in general, my current feeling is React Native CLI is the best option. Others are only for certain cases. And actually, that's basically it. There are much, much, much more to talk about, and probably it will be another lightning talk or maybe an article or something, because I feel very excited about this technology. I like how I can start building native applications without writing code in Objective-C and Swift. I still need to understand architecture. I still need to understand some specifics of native development, but this is the same for web. You can't just use React to build a good website. You need to understand how websites work, how HTML, JavaScript, CSS work. Otherwise, you won't be able to deliver something good. The same with React Native. What I plan to learn more and deep dive into next. Linking external libraries and modules. One example, if you're interested what it is, and there are tons of different libraries and modules. Ecosystem is very mature in React Native. One very simple example is React Native device info. You can go open it, and you will see that part of the code is written in JavaScript and another part in Java and another part in Objective-C. And this is how React Native modules are built. Styling and UI kits is another huge topic to review, and obviously to pick UI kit that is good for you, for your company, for your purposes. There are several very good mature UI kits. Another topic is backend authentication and some tools that can help with backend. It turned out that there are tools that allow mobile developers to kick off project without any backend knowledge, without any backend developers in the team. They just connect some services that provide, and their libraries corresponding libraries that allow to very quickly kick off the project with authentication, push notifications, data storage, image uploading, and so on and so on. Going live, another interesting topic, because obviously we built our application, we have it running on our simulator, how we can publish it to Android Play Market and to iOS App Store. CI and automated testing. There is official integration orb for Circle CI built by React Native community, which is great. They use Circle CI, and Weird System Suite use Circle CI as well. And there they can build applications. They can run end-to-end tests. There are frameworks for running end-to-end tests, which is also great. Over-the-air updates. Very interesting feature of React Native. Obviously, you have your JavaScript bundle, which you don't have to compile into your application. You can deliver it using network. And there are tools that basically provide updates over the air. Instead of uploading new version of your application in Play Market or App Store, if it's minor update that required only JavaScript changes, then you can deliver this update using CDN. Let's say your new JavaScript bundle is compiled and stored somewhere in S3, for example, and then your users, when they have internet connection, will automatically download this new version and will use new version of the application. But some applications are blocked because of this feature, because, for example, App Store, Apple, they are not happy with this over-the-air updates, but still worth looking into. Another problem is analytics, because we don't have URLs, and so we can't just integrate Google Analytics or something into our application. And there are certain solutions to this problem, how you track users on mobile. Security and secrets management, another problem with mobile apps. They should be working in offline mode, but at the same time, you can't have your secrets compiled into your application because it's not secure. It's easy to decompile and find your secrets inside your application code base, and there are certain approaches and tools how you can secure your application. And finally, there's interesting topic, how you can build cross-platform applications that will run on web, on mobile, on desktop, and so on. That's quite a lot of investigation, so stay tuned. And while you are waiting, please feel free to install React Native, follow React Native tab, and make sure you have about 20 gigabytes of free disk space on your machine, because you will need to download quite a lot of stuff if you want to be able to test on different devices. If you want to test just on iPhone, then you don't need to install everything, but I preferred to install everything. And I found this guide, React Native guide, the most unopinionated guide that doesn't suggest you to use any third-party tools and tries to be generic and friendly. I liked this guide, and I recommend you to follow it if you want to get started. You will get good first understanding of React Native. Thank you very much.
Thanks, Kate. Thank you very much. Very interesting and very cool. Very nice.
Yeah, it's very interesting. Obviously, it's been floating around for a long time in the tech world, and the idea is simple enough, isn't it? Like make a fully cross-platform, one source of truth kind of application that compiles into all the different things. It's really cool. There's one question I actually had about how styling is done, because I saw that in the examples and also the thing that you did, that it was mostly just kind of setting up a sort of pseudo style sheet in JavaScript itself and then putting it in. So I'm wondering what that means for the standard CSS paradigm of classes and IDs, which is very useful also to do, to be more efficient, or to have a whole like style sheet management. How is that done in React? In React Native, yeah.
So I recommend you to check Ignite templates to see how it can be done. The idea is that you organize the style sheets and break it into on per component basis and include them on per component basis. So you will not have classes, but you will kind of include this specific style sheet for this specific component. So it will not be in one big style sheet. So you can create as many style sheets as you want, but it's not like CSS. It's a little bit different.
Okay, so basically the concept of classes and IDs that are defined by the developer fall away, right? Because it's then generated to a certain extent.
So the templates from Ignite showcase how you can reinvent classes. They basically provide preset property, and you can say preset primary, and then you load style sheet with this name, and then you can combine multiple style sheets. So you load style sheet button, you load style sheet primary, you merge them and apply to this button. And as a result, you have kind of CSS.
Okay, I'm just wondering what it means for third-party tools that track DOM elements like in the web browser for all kinds of purposes. I mean, obviously with our client, we use them a lot. So what would that mean? Like how would I be able to identify DOM elements based on, CSS classes or IDs?
So if you are talking about React Native for web, then I don't know. I haven't tested it. I don't know. Sorry.
Do you know how much native programming experience one would need? Like, is the majority of programming experience on React Native just JavaScript?
Yes, that's the whole idea, and that's the huge benefit. So you basically can start developing a native application with just JavaScript and React experience. But when you want to do something real and of good quality, you will need to learn a little bit more about ecosystem in general.
So for advanced applications, you would need a experience in the native basis of Android or iOS.
You will need to understand it. So many people who shared their experience with React Native, they say that you may need to read a little bit to understand what is going on, especially when implementation of timers, for example, it's spread between native and JavaScript. And when you have a bug related to timers, you will need to dive into it and understand a little bit beyond JavaScript. But it's much better than having to learn Swift, Objective-C, Java, Kotlin, and all components across two platforms.
I'm not sure that I understand about CSS. Does it mean that I can to connect CSS from CDN, for example, to mobile application?
No, you
Or,
can't. It doesn't
okay.
make sense. It will not help.
Yeah, and because we have style sheet in JS, yeah, we need to use JS for style sheet.
I saw some libraries that allow you to connect, to write style sheets using good old CSS syntaxes, but under the hood, it will still do the same. It will create this React Native style sheets and apply them to elements, because it's not executed in browser. It will be then transformed into native properties, style and properties, and native applications. They don't use CSS. They use their own style and approaches. That's why it's a bit complicated. But in fact, when I saw some examples on the web, it looks fine. And as I mentioned, there are plenty well-established UI kits. Again, I haven't had a chance to review them, but I have a feeling that there might be some very nice UI kit that helps you deal with it.
Okay, and I had another question about how did you install your application in your debug example on your mobile, but you said that it will be another topic. Yeah.
Oh,
Or
I mean, how that video?
How did you install your application, test application, in mobile? You just upload file
No.
to mobile or something?
So I just use React Native built-in commands, and one of them, React Native run Android, for example. So you have Android Studio installed on your machine, and Android Studio, you don't use it to build Android application, but Android Studio will see when your Android application is connected to your laptop, and it will make it available for React Native, but in fact, it's not React Native, it's another utility. It's a little bit too much detail for the intro, but in general, it happens almost magically. You just install all the things, you run React Native, run Android, and it will find available device, either simulator or real device if you connected real device, and it will install your application automatically on your device, and it will connect your application to debugging tools on your laptop, and then it will in real time update your application so you can play with it, and then you can see in debugger some output. The debugging experience is very, very good, at least on the recent React Native version. Sorry, Pavel, I can't hear you.
I say it's great. It means I can connect. I can connect a couple of devices, for example, iOS and Android, in the same time, and I can debug both in the same time.
I haven't tried to debug both.
Okay.
That's an interesting idea, but at least you can do it in sequence. First debug on Android, then debug on iOS.
Yeah, but it will take a little bit more time for debugging if you have some bug, for example.
That's why I
You
love
can just
web.
put very much mobiles and look on all of them.
I don't know. Maybe there are tools to connect and debug on multiple devices at the same time. I haven't seen anything like this.
Okay. So,
Shall we wrap up?
I think yes.
Cool. Thank you very much, guys.
Thank you, Kate.
Thanks. Bye-bye.
Thanks.
Bye.
Bye.